Hello student, we'll see peak detector. Peak detector is a circuit is one of non-linear application of op-amp. It is used to detect and hold the peak value of input signal. So there are two type of peak detector, positive peak detector and the negative peak detector. The positive peak detector will detect the positive peak comes in the input signal, and the negative peak detector will detect the negative peak comes in the input side. So this is the circuit diagram. Here is the op-amp with voltage follower configuration. So for that, the gain of this is equal to 1. So two diodes are connected, D1 and D2. This D1 and D2 will assume that it should be ideal. So the whatever the voltage appear across this will be as equal to the voltage across this capacitor. So when the positive half cycle comes from the op-amp, or we say if the positive half cycle at the output of op-amp will make the for this D1 forward bias and D2 will be reverse bias. Now initially the voltage across this capacitor is equal to 0 volt. So the first positive half cycle when comes, the same output will be first positive half cycle. See, this is non-inverting configuration. So if you give the positive half cycle, the output will be positive. And this positive half cycle makes this diode D1 forward bias and D2 in reverse bias. So due to this, the capacitor will start charging. The capacitor will charge up to the positive peak voltage. So this operation is divided into two parts. One is a track mode and another one is hold mode. This is non-sinusoidal output voltage. So in this non-sinusoidal output voltage, we have to find out the peak of this input signal. So as I say, this operation is divided into two mode, track mode and hold mode. During the track mode, the capacitor will get charged up to the positive peak. You can see over here, this is the track mode. During this track mode, the capacitor will get charged up to the peak value. When the negative half cycle comes, or we can say the voltage will start decreasing. You can see over here the voltage are decreasing. In that case, the diode will get reverse bias or turn off. So in that case, the whatever the peak voltage across the capacitor will hold for that moment. So this is the hold. This hold period will be last long up to the next peak of the input signal of the diode. Where the next peak will comes at the op-amp, at the output of op-amp, the capacitor start charging to that peak value. As it charge, it will hold for the next half cycle. Here you can see over here, the first peak comes over here. The capacitor is get charged up to the peak of that output of op-amp. It hold for a moment, and as it found that the next peak comes, the capacitor will start charging from that point to next peak value. And this will last long up to the next higher peak. If after the higher peak, if some lower peak comes, the capacitor will hold for that earlier peak voltage. So the charging time of this capacitor should be less than T by 10, and the hold time will be greater than 10 time of total time. The application of this peak detector we can find over in test and measurement instruments, and this peak detector will be found in amplitude modulation detector, where we have to find out the peak of the audio signal. In negative peak detector, the diode direction will get reversed. So here diode will get replaced with like this. So in negative peak detector, the diode will conduct for negative half cycle. If the negative half cycle comes, that time diode will be forward bias. So here it will the capacitor start charging for the negative peak, and it will hold for next negative peak cycle, and as it found that whether the next negative peak comes, then capacitor again start to that negative peak value, and it is lost long for the next higher peak. Thank you, student.